Hello everyone. Today we are going to start with discussing important topic from data structure, and that important topic is linked list. List which is linked. Here what all points we are going to discuss. These points are, we are going to begin our discussion with concept of linked organization. Why there is need of linked organization, whatever queue and let's say stack we have seen, what are the limitations of array representation of queue and stack. Okay, then we will talk about singly and doubly linked list. After that we will discuss about dynamic storage management. Then we will talk about circular linked list. Then operations such as insertion, deletion, concatenation, traversal of linked list. Then dynamic memory management, and finally we will conclude this unit with garbage collection. So begin with, let's understand first the concept of linked organization. Linked organization means what? Data is linked with each other. One data is linked with other data. Okay, so before understanding the concept of linked organization, we must understand what are the limitations of sequential organization. Whatever limitations of sequential organization. See here, array is the most common data structure which is used to store collection of elements in sequential organization. We know that array elements are stored in sequential manner. In this case, the index of the first element is 0, index of the next element is 1, next element is 2, and so on. That means the elements are stored in a sequential manner. This is nothing but a sequential storage. Here the size of the array is fixed. Initially we need to declare size of the array, assuming that int a equal to int a in square bracket 5. It means that this is an array of size 5. That means it require its number of elements will be 5. Okay, so the size of array is fixed. Most often the size is specified at compile time. At compile time means when we compile the program, at that time only the size of the array is declared. This makes the programmer to allocate arrays which seems large enough than required. So because of this, programmer has to declare array size large enough whatever is required. For example, we don't know what will be the length of postfix expression. We don't know what will be the length of postfix expression. That's why when we are declaring array for that purpose, for accepting the postfix expression, we declare the size as 20, because we don't know how many characters will be there in our postfix expression, right? So here programmer has to declare what? The maximum size. Now user may enter a postfix expression having only 5 characters, next time maybe 10 characters, next time maybe 8 characters, next time maybe 15 characters, including the operands and operator both. Okay, so here in case of array size needs to be declared first. Okay, inserting new element in the front is potentially expensive because existing elements needs to be shifted over to make room. We know that index of first element is 0. Now if I want to insert an element at the beginning of the array, is not simple. What we need to do? We need to shift all the elements and we have to make 0 index element available, so that the new element entry will be made at first position and then remaining element will be at the next to the first position, right? So this is the expensive task because we have to do lot of mathematics. Okay, so deleting, again, if I am deleting an element from middle of the array, that is also very difficult. That means assuming that I have 5 elements, 1 2 3 4 5, I want to delete element number 4. So what should happen after deleting element number 4? Element number 5 should come at the place of element number 4. So again this task we have to do, and these are nothing but some of the limitations of array. For example, in system, if we maintain a sorted list of IDs in array ID, for example, I have created your class list, and which is sorted with roll number. Okay, now as you are taking the admissions, I am inserting into that list. Initially roll number 5 has taken the admission, then let's say 7, then 11, then 20, then 25. Okay, then all these numbers are in increasing order, and now roll number 3 has taken the admission. So what I need to do, I need to check where I should put roll number 3. Roll number 3 should be before roll number 5, right? So accordingly I have to adjust my list. So, and if we want to insert, see what is the list? ID 10,000, 1,000, 1,010, 50, 2,000, 2,040. It is sorted. Now if we want to insert ID 1005, 1005, then see it should be here, right? It should be here. So to maintain the sorted order, we have to move all elements after 1,000 excluding 1,000. So what we need to do, we need to move all these elements, and then we have to insert this new, that is 1005 here. That is what we need to do. Again, deletion is also expensive with arrays until unless some special techniques are used. For example, to delete 1010, that means I want to delete this. So what needs to be done? 1050 should come at this place, then 2000 should come at this place, 2040 should come at this place. That means we have to move all other elements which are appearing after 1010, after 1010, 1010, right? So these activities are nothing but expensives. For example, to delete 1010 ID, everything after 1010 has to be moved. Everything we need to move, and that is the expensive activities. Okay, so this is nothing but the sequential organization, that is the array example. And what are the limitations of array? That is what we have discussed. Limitations of sequential organization. Now we will talk about the concept of linked organization. Here our data is not in a sequential order. Data is not in a sequential order. So see here, one solution to the above problem, that means sequential organization problem, inserting in middle or deleting from the middle, whatever problems we are facing. So solution to this problem is that instead of using sequential representation, a linked representation or linked organization should be used. Now we are not using sequential organization, we are going for linked organization. Unlike an array, now it is not like an array. What we do in array, where elements are stored sequentially in memory, in case of linked representations, items in list may be located anywhere in the memory. Elements will be located anywhere in the memory, but they are linked with each other. How it is, we will see. To access elements in the correct order, we store the address or location of the next element with each element of the list. That means in linked organization, every element is associated with the address of the next element. That means element number 1 will have associated with address of element number 2. Then element number 2 will be associated with address of element number 3. So when we want to access any particular element, we will be accessing them in sequentially. From 1 we can go to 2, from 2 we can go to 3. Linked organization is one in which the elements of the list are logically next to each other, but physically they may not be adjacent. Now before looking at linked list, I will just give you one example of the linked organization. See what happens actually. Okay, here we have the space. See here. Now when we create first element, so this is the first element having the data part, and address of the next part in linked allocation. Okay, now assuming that this is our memory, computer memory, which is divided into different blocks. Okay, so let me write these blocks are like this. These are different blocks of the memory. Okay, now block number 1, block number, different blocks are there. Okay, and now one block of memory is used for storing one particular element in the linked list. Okay, now this is nothing but one element in the linked list. This element has address of the next element. Assuming that when next element is added to this linked list, the memory allocated to this data part is, for example, this is the memory allocated to that second node, okay, or second data part we will say. So what happens, address of this, we know that every memory block in a computer has specific address. So address of this block is stored in the first block, and this is nothing but the link from first to second. Now assuming that third block is created, that is for third element. Then what happens, in second block address of the third is stored. Now these blocks are not in contiguous memory locations. These memory blocks are not in contiguous memory locations. In case of array, see, we have calculated the memory representation of arrays. First element if having memory address 2000, if it is an integer array, then address of the next element in that array will be 2002 if every element requires 2 bytes. If every integer element requires 4 bytes, then 2004 will be the starting address of the next element. So 2000, 2004, 2008, 2012, 2016, these are nothing but contiguous memory blocks, and that is in case of sequential organization. In case of linked organization, address of this block may be, let's say, 1000, address of this block may be 1060. Is there any relationship between them? No, they are random. Address of this block may be 1030. That means one data element from that list is stored at location 1000, another is at 1060, another is at 1030. They are physically far apart from each other, but they are linked as index, as the address of the next is stored in the previous data element. Is this clear? That's why this is nothing but linked allocation. Now one point that I have told you, see here, the elements, to access elements in correct order, we store the address or location of the next element with each element. Linked organization is one in which elements of the list are logically next to each other, but physically they may not be adjacent. Now here you can see the elements are not adjacent, but logically they are adjacent to each other. Why? Because we have address part. We have address part in each of the data part. Data मध्येच address part आहे. ठीक है? Is this clear to everyone? Okay, fine. So one of the example of linked organization is linked list. So here now we are going to start for the discussion on linked list. Okay, so initially we will begin with basic concepts of linked list, and then I will explain you how actually linked lists are created. Okay, so what is linked list? A linked list is an ordered collection of data elements where the order is given by means of links. That is, each item is connected or linked to another item. That means we will have item number 1. So this is nothing but my, let's say, element number 1. Then element number 1 is linked with the element number 2. Then element number 2 is linked with the element number 3, and so on. So this is nothing but the idea of linked list. How the links are created? By using addresses of these nodes. Okay, so basically linked list consists of the nodes. So single element of the linked list is called as node. Single element of the linked list is called as node. Each node contains an item field and a link. So every node, whatever we are going to create for a linked list, will have two parts. One is called as the data part and another is called as link part or address part. This node is going to have, let's say, element value 10, and here address of the next node belonging to the same list. Okay, so the item field may contain the data item or link. Now whatever item field we have, that is going to contain an data item, or here we will have a link to the next element. A linked list is a non-sequential collection of data items. Linked list is non-sequential. See, elements are not sequentially organized on a physical memory. They are far apart from each other. So that's why it is non-sequential collection of data items. It is dynamic data structure. Why it is dynamic data structure? Because I may say I want to create a linked list of 3 nodes. So linked list will be created with only 3 nodes. Then I may be saying that I want to create a linked list of 5 nodes, 10 nodes. So as number of nodes I am going to change, the size of linked list is also going to change. That is not the case that is not with the case of arrays. In array we need to declare the size at the beginning of the program. Right? At the beginning only I need to declare the size of the array. But in case of linked list, no need to declare size. Is this clear? Okay. Now, for every data item in a linked list, there is an associated pointer that would give the memory location of the next data item in the linked list. That means with every element or item in the linked list, it is associated with the pointer. And we know that pointer contains the address. So what it contains actually? It contains address of the next data item in the list. The data items in the linked list are not consecutive memory locations. They are not at consecutive memory locations. I shown you the memory blocks. They are far apart from each other. They may be anywhere, but accessing of these data items is easier as each data item contains the address of the next data item. So data item 1 will contain the address of data item 2. So by using that address we can easily navigate from element number 1 to element number 2. Is this clear? Okay. Now let's talk about the representation of linked list. Representation of linked list. So a linked list is represented by a pointer to the first node of the linked list. How it is, I will show you. First node is called as head node. So whatever first node we are going to have in our linked list, we are going to call it as a head of the linked list or head node of the linked list. Then if the linked list is empty, then value of the head node will be null. That means if I don't have any single element in my linked list, that linked list will be empty. In that case, value of the head node will be null. Is this clear? Each node in the list consists of 2 parts. What these 2 parts? A data part and a pointer or reference to the next node. Now let's begin. See here. A node is created which is empty. That means there is no any data part in my linked list. So first node is created, data part is A. So this is called as head node. Why? Because it is first node in my linked list. It is what? First node in my linked list. That's why I am calling it as a head of the linked list. Now I am creating one more node, node B, and node B should be the second in my linked list. So what I do here, whatever address part we have in our first node, we store the address of second node into the address part of the first node. Address part of the first node. And again I want to create one more node, node C. So here address part of second node will contain address of the third node, C. And if C is my final, if that C is my final node, then address part of this last node will point to null. Will point to null. So here what is data? B, this is nothing but the data part, and this second, this is nothing but the pointer part. Is this clear? Data part, pointer part. Now in C we can represent a node using structure. Our objective here is to understand how to represent a node in different programming languages. So here we are going to focus in C language. Okay? So let us see an example of linked list node with an integer data. Means we are going to create a linked list node and data component will be integer. So how to create this? It's very simple. So this is a comment line. what it is saying? A linked list node. Struct keyword is used. Struct keyword is used to create a structure. Okay, and now node is nothing but name of the structure. As I am creating linked list node, I am giving name to this data structure as node. This structure as node. Now I know that every node of the linked list contains how many parts? Two parts, data part and pointer part. So here I will be having int data part, and second we will have star next, that is pointer part. Now every pointer field contains what? Address of the node itself. Address of the node itself. That's why data type of that pointer should be what? Node. Why node star next? Because it contains address of the next node. It is not containing address of any single integer or any single character or any single variable. It is containing the address of the node. That's why we have to create a node pointer. That's why we have to create a node pointer. So that's why we have written here node star next, and here the type, that is struct, because it is pointing to the structure node. Because it is pointing to the structure node. That's why this is the definition of node in C programming language. I will be showing you demonstration how to create a single node. Okay? Now, advantages of linked list. What are the advantages of linked list? Very interesting. Linked list have many advantages. Some of the very important advantages are linked list are dynamic data structure. That means in case of array, we need to declare size at the beginning of the program, at the compile time. Here, no need to declare the size of the linked list. They can grow or shrink during the execution of program. During the execution of program, linked list size may grow, may decrease depending on the requirement. That is nothing but one of the most important advantage of linked list. Then linked list have efficient memory utilization. Here memory is not pre-allocated. We are not initially allocating the memory. For example, I am creating array of 10 elements. For example, 100 elements. So what I am creating, see here, I am creating int a is name of the array and size is 100. So how many memory will get allocated to a array? That is 100 number of elements multiplied by size of each element, assuming that size of each element is 2. So total memory allocated to a is 200. Assuming that I am accepting only 10 elements. Assuming that I am accepting only 10 elements. So how much is utilized? 10 into 220. 180 memory is wasted. Is this clear? 180 memory is wasted. In case of linked list, I have to create 10 nodes. So initially I will be creating one node, allocate memory. Second node, allocate memory. Third node, allocate memory. That means whenever we are creating new node, at that time only we are allocating the memory to that node. So there is no wastage of memory. Jitke node ahet, whatever number of nodes we have, only that much memory is allocated. When we are deleting, for example, we are having 5 nodes. One node is deleted, 4 is available. So whatever memory was allocated to this node, that memory can be deallocated so that it can be used for other purposes, for storing other data elements. And that is the advantage of linked list. Clear everyone? Memory, see, memory is allocated whenever it is required and it is deallocated or removed when it is no longer needed. That is the most important advantage of linked list. Insertion and deletion are easier. Insertion and deletion are easier and efficient. Linked list provides flexibility in inserting data item at a specified position and deletion of the data item from the given position. That means we can delete data element at any location without any difficulties and without hampering the other elements. How it is, we are going to see this. In detail, I will be showing you how to insert a particular element in between two elements or two nodes of the linked list. How to delete from in between two nodes, that is also we are going to discuss. Okay, so are these all advantages clear to everyone? Okay, and finally, many complex applications can be easily carried out with linked list. So these are nothing but some of the advantages of linked list. Now we will talk about disadvantages of linked list. What are the disadvantages? Number one, it consumes more space. It consumes more space because every node requires an additional pointer to store address of the next node. For example, in case of array, single element will require that much memory which is required for that single data type. For example, integer data type required 2, that only used by item 1, element 1. But in case of linked list, we should have two memory blocks, one for the data part and another for pointer part. So the memory which we are using for pointer part is the additional memory usage. Okay, so that is nothing but it consumes more memory as required for additional pointers. Okay, then searching a particular element in the list is difficult and also time consuming. For example, in case of array, I want to display element number 5. What I will be doing? A of 5 or A of 4. Index starts with 0. So A of 4 or A of 5 will give me that number. But if I want to display element number or node number 3, we can't directly display element number 3. We have to start from the beginning. That means we have to visit node 1, node 2 and then node 3. That's why in case of linked list, searching a particular element in the list is difficult, also time consuming. Why time consuming? Because we have to begin from the first node every time. Assuming that I have 100 nodes and I have to search 99th node. Node 1, 2, 3 and up to 99. So that all things we need to do. That is nothing but another disadvantage of linked list. Now let's talking about malloc and free function. Malloc is what? Memory allocation, and free is what? Freeing the memory which is allocated to the node when node is deleted. When node is deleted. Now let's talk about malloc function. Malloc function is what? Malloc is a system function in C programming language which allocates block of memory in heap memory and returns a pointer to the new block. It means that it allocates a block of memory to a particular data part, that whatever we are going to create. Okay, so basically malloc is a system function which allocates block of memory in heap memory. Now the prototype of malloc and other heap functions are in stdlib.h. So when we are going to use malloc function, we have to include stdlib.h header file. When we are going to write program by using this linked list and when we are going to use malloc function, you may be getting errors. Why? Because you may not have included stdlib.h header file. So make sure that you are including stdlib header file. Okay. Malloc returns null if cannot fulfill the request. Assuming that we require 10 memory blocks, and if that much memory is not available, then this malloc function returns null. It means what? That much memory is not available. Now it is defined by how the malloc function is defined. It is defined as void star malloc number of bytes. Here we are passing a parameter, that is number of bytes, how many bytes we want to allocate, and this malloc function returns what? It returns a initial address of that memory block. Whatever memory block it is returning or it is allocating, initial address of that memory block is written by the malloc function. That's why star is written here. Is this clear to everyone? Okay. Now since a void star is written, The C standard states that this pointer can be converted to any type. For example, character star CP, that is character pointer equal to character star malloc 100. Now why character star is used? Because we are allocating memory to set of characters. Now we may have, instead of char, integer. That means we are allocating memory to the integer elements, lot of integer elements. Okay, this function attempts to get 100 bytes and assigns the starting address to the character pointer. We can also use size of functions to specify the number of bytes. How many bytes actually we want to assign? Assuming that I want to create 5 nodes, for example, or I want to create array of 5 elements, array of 5 integers. I know that how many elements are there? 5. Every element requires how much? 2. So what I can do? Size of int. So size of int is how much? It will return that value, and 5 multiplied by. So 5 multiplied by size of int, that is 2. 5 into 2, 10. 10 block memory will be allocated to the pointer. Integer pointer or character pointer. Integer character pointer असेल तर size of character. Size of character is 1 byte. So 1 into 5, 5. 5 blocks will get allocated. If it is integer, then 10 blocks will get allocated. Okay, so we can also use the size of function to specify number of bytes. For example is pretty simple. Int star integer pointer, IP for integer pointer. See here, int star malloc 100 into, see, number of elements are 100, and then size of int is 2. So 2 into 100, 200. So initial address of this 200 block, whatever 200 block we are going to get, its initial address will be stored in IP, integer pointer. Are you getting this? So that means this pointer is going to point to a memory block of 200 size. Is this clear to everyone? Okay, so this is nothing but the way in which we declare the malloc function. Okay, now let's talk about free function. Free function is what? Exactly opposite of the malloc function. It deallocates the memory. What it does? It deallocates the memory. The argument to free is pointed to a block of memory in heap pointer which was obtained by malloc function. Syntax is very simple. Free in bracket ptr, that means pointer that we have created. We have created CP, we have created IP, so we are going to use just free CP in bracket CP or free in bracket IP. What it is going to do? It is going to deallocate the memory which is allocated to these pointers. Now after freeing, what will happen? That particular memory block can be utilized for storing other elements, for storing other data elements. That is the advantage of the free. So advantage of the free is simply memory management when we no longer need a block. Simply do the memory management. That means we no longer need that particular memory block that can be utilized for storing other data parts, other data components. That is the advantage of free. Is this clear to everyone? Malloc and free?